This is the video for the review sheet for tonight for tomorrow's test on rational functions, those functions that are fractions that we looked at, their transformations, shifting them left and right, and the exponents, and then we used them for looking at solving equations that had some fractions where the variable was in the denominator. So let's look at some of those problems. Question 1, we're looking to simplify. Remember, simplify does not mean solve. We're going to get not an answer for x. We're not going to know that x equals. There's no equations. We're just looking to make them look different but mean the same thing, stay equivalent. So anytime you have division, our first step is to flip the fraction that you are dividing by. So before we do anything else, that is the number one priority. And it changes when you flip it into multiplication. Now, once it's multiplication, we can look to start canceling out terms that are the same in the numerator and the denominator anywhere within the problem. So, cancel out. And there's nothing else that looks exactly the same, but I do see 20 and 5. And I know that 20 divided by 5 is 4 over 1. And I have x to the 6th and x to the 8th. That means I have 6 x's multiplying in the numerator and 8 x's multiplying in the denominator. These 6 are going to go away, leaving behind the 2 in the denominator that don't cancel. So what's left behind? Well, on the top in the numerator, I've got x minus 3, gone, a 4, and nothing else. And in the denominator, all that's left is x squared. For b, we're looking to add two fractions. You add two fractions by getting common denominators. So first, recognize 7 as 7 over 1. And second, let's get them to have that same denominator. So we have 5 over x plus 2 plus distribute 7x plus 14 over x plus 2. And now we can combine them into one fraction. I have 7 plus, well, there's only just the 7x. There's nothing to add it with, so we have 7x. And it is plus 7x, so it stays plus. And 5 plus 14 is 19. The next question, same idea, fractions. Let's get a common denominator. So we're going to multiply our right fraction by x plus 5 and our left fraction by x minus 3. Take a second to note that the denominators are both x minus 3 times x plus 5. So we have x minus 3 times x plus 5. And the numerator, you distribute. You get x squared minus 5x plus 6 plus same denominator because we wanted that common denominator. And in the numerator, we distribute. We get 3x squared plus 5 times 3, which is 15x. We can combine these into one fraction, x minus 3, x plus 5. Combine like terms, x squared plus 3x is 4x squared. Negative 5x plus 15x is 10x. And we have a plus 6. And we can look to try to factor these the polynomial that's in the numerator. However, that is something that I do not want you guys to have to worry about. So that answer will be perfectly acceptable. Yeah. D, we're looking to add fractions, very similar. Multiply, get a common denominator. This time, instead of addition, we're looking at a subtraction problem, so remember to be careful with that negative. The first fraction, distribute. 8x plus 48 over x plus 6 minus, distribute, x squared plus 2x over x plus 6 times x, don't forget that common denominator, and combine them together into one fraction. I have 8x minus positive 2x is a 6x. I have subtracting a negative x squared, so I have minus x squared. This was a positive 6x, and I have plus 48, and that will be our final answer. For part E, we're looking to multiply two fractions together, and we're going to look to reduce before we multiply. So 14 and 7, those reduce to 1 over 2. I have x cubed, that's 3x's, and x to the 5th, that's 5x's. 3 of them will cancel, leaving none in the numerator and 2 in the denominator. And I have x plus 2 once and x plus 2 twice in the denominator. 1 will cancel with 1 from the denominator. There's nothing that didn't cancel in the numerator, leaving just a 1. And in the denominator we have 2 and x squared and an x plus 2. And our last portion here, question F, we're looking to add once more. This time the fractions already have one term in common in the denominator, but the x minus 3 in the second fraction is absent from the first fraction. So we're going to multiply by x minus 3 in the denominator, and whatever you do to the denominator, also do to the numerator. Don't forget to distribute. You have 5x minus 3 times 5, which is 15, over x minus 3 times x plus 7. We are adding in the original problem, so we're adding 2 over x plus 7 and x minus 3. Our common denominator is x plus 7 times x minus 3, and we add like terms in the numerator. 5x plus, there's no x's, so just 5x. Negative 15 plus 2 is minus 13. Question 2, we're looking to graph. For each of these, the first thing we do is plot our asymptotes. So here we have plus 4, so we have an asymptote that's shifted backwards to negative 4, and note the asymptote equation will be x equals negative 4. Our vertical asymptote is drawn. Our horizontal asymptote, we know we shift up 6. So that's where y equals 6. And now we have to draw our graph. Our graph is looking at something with an odd exponent and a positive coefficient. So we'll have this shape. And the last thing we want to do is label a point in the graph. This point here, we move 1 to the right from negative 4 to negative 3, 1 above 6 to 7. Our second equation, we shift to the right 6 to x equals 6, and down 2 to y equals negative 2. We are looking at an even exponent, so our pieces of the graph will be together, but it's negative, so they will be together pointing down. And a point in the graph here, we go 1 to the right from 6 is 7, 1 below negative 2 is negative 3. Our last graph, there's no shift left or right, so the asymptote is at x equals 0. We do shift down 8 to y equals negative 8. And we're looking at a shape that is odd, so the pieces will be across from each other, and it's negative, so they will be the opposite of what we had in part A. Pieces would shape this way. This point right here, 1 to the right of 0 is 1, 1 below negative 8 is negative 9, and that is the front half of the page. On the back, our first questions are solving. Whenever we're looking to solve, get rid of a division, we're going to multiply. Specifically, we're going to multiply by whatever is the denominator, so multiply by x plus 3. And that's good on this side of the equation because those will cancel and leave behind just 5. But if we multiply one side of the equation by x plus 3, we also multiply the other side. And here we want to make sure to distribute. So we have 8x plus 24 equals 5. Subtract 24. We have 8x equals negative 19. So x is equal to, if you divide by 8, negative 19 eighths, which is the same thing as negative 2 and 3 eighths, which is 0.375. Second question, we're looking to do the same thing with our fraction, but there's this plus 3 there. We want to move it first. That way we have just the fraction alone on one side of the equation. We subtract the 3 from the 9 and get 6. And now I want to get rid of the fraction. To get rid of a fraction, we multiply by the denominator. Whatever you do to one side of the equation, we do to the other. Don't forget to distribute. We have 2 equals x squared. 6x and 5x make 11x. And 6 times 5 is 30. Subtract 2. We have 0 equals x squared plus 11x plus 28. This is a quadratic. We could use the quadratic formula, but this one will factor nicely. X plus, 28 is 7 times 4, and 7 and 4 add up to 11. So we get that x is negative 7, x is negative 4. For all of these, but both A and B, we should always make sure to check our answer by plugging it back in. I believe these ones will all work. Here we're looking to sketch a graph. So I know from this one that we're going to shift right 2 and up 5. And there's no exponent, so it's an exponent of 1, which is odd. So the pieces are going to be diagonal from each other, but it's negative, so they'll be diagonal in that way. And we are looking to sketch the graph and give the equations of the asymptotes and a point for each function. This asymptote we shifted right 2. This asymptote we shifted up 5. This point here is 1 to the right of 2 at 3, 1 below 5 at 4. And I'm going to do one other question here as well. aside from our asymptotes and the point, is I'd also like to take a second to tell you domain and range. The domain of this graph, it goes all the way to the left forever, so negative infinity. It goes all the way right, no point where it stops, we go to infinity, but it skips over when x is 2, so we say it doesn't equal 2. The domain, there is no lowest value, so it goes to negative infinity. There is no highest value, so it goes to infinity, but it doesn't ever have a value of 5. Our second graph, we shift left 2, down 3. We have an even exponent and a positive coefficient, so the graphs will go together and point up. This one shifted left 2 to negative 2, down 3 to negative 3, and this point here will be 1 to the right of negative 2, negative 1, 1 above negative 3 at negative 2. And let's do the domain and range again here for practice. There is no furthest left point, there's no furthest right point, but we skipped negative 2. For the range, there is a lowest point. The graph never goes below negative 3, and it goes up to infinity. And if you want to, you can say that y doesn't equal negative 3, but we already said that here by not putting a line below the inequality, so we don't really have to say that. It's kind of redundant. We can just leave it in that form. That is what we're looking to do. Other questions that might come up, if you're told to find out when this equation here might be, instead of equal to y, when would it be equal to 4? You would find where the line y equals 4 is, which is right here, and you can see that they cross at that point. So anytime we're looking to solve an equation by graphing, you're looking for the intersection of the graphs. So here, if we set the equation equal to, say, y equals x plus 1. So you'd have a line that looks like this, looks like they cross somewhere, you'd have a nicer graph and you'd be able to give a very specific answer. If you wanted to get the actual answer, that's where solving by hand algebraically is more useful. And that is our review sheet.